All right, so today we're going to be covering solubility. Solubility is going to help us determine the solvent and solute in a solution, and it will also help us identify ways to increase the rate of a solution. Okay, so quick question. How do you like your Kool-Aid? Obviously, we don't really have a chat. If you'd like to leave a comment on this video, feel free. But how do you like your Kool-Aid? I like mine. I used to when I was younger, like mine, like super sweet, like it was gonna give me diabetes. I'm older now and I can't handle that much sugar, but I do still like it to be pretty sweet. So looking at these pictures here, which one do you think has more Kool-Aid mix? Going from 1 to 5. Perfect. If you said 5, you're probably right. Like if you've made Kool-Aid, then you know that the number one, they didn't even put a little bit of the packet in. Number two, it's still got a little bit of clear there. You could probably do with some more. 3 and 4, depending on the flavor of Kool-Aid, I would say has like a whole packet of Kool-Aid in it. But 5, I've never seen Kool-Aid this dark, which means that maybe they even use like more than one Kool-Aid packet, right? Okay. This scale goes from diluted, which means it has more water in it, than Kool-Aid mix, to super concentrated, which means that it has more Kool-Aid mix than water in it. Okay. That's pretty much the basis of solubility. So when we first started learning about chemistry, we learned about matter and its breakdown into different types of substances, pure and impure. We've already talked about the elements, we've talked about compounds, metals, nonmetals, metalloids, etc. Today, we're going to start talking about impure substances, specifically homogeneous mixtures, aka solutions. So, what is a solution? If you can cast your mind way back when to the beginning of class, we learned that a solution is just a homogeneous mixture of two or more substances in a single phase. So, that means that it's either a solid, a liquid, or a gas. Solutions are composed of two or more substances, and each of those substances keeps their own chemical properties. So, going back to the Kool Aid example, we use 3 different substances to make Kool Aid. We use water, we use the Kool Aid packet, and we use sugar. The water is keeping its own chemical property by making it a liquid, the whole thing a liquid. The Kool Aid packet provides the color and the flavoring, and then the sugar provides the sweetness. All 3 of those things had to keep their own chemical properties in order to impart the different Kool Aid situations into it. Examples of solutions are salt water, apple juice, and dust-free air. The air that you normally see, sometimes if you look at air in the light, you can see particles, dust particles almost. Those are mixtures of nitrogen. Those are like, that's not dust-free air. That's not what we're talking about. But dust-free air is a mixture of nitrogen, oxygen, argon, carbon dioxide, water vapor, and a few other gases like methane, for example. Solutions are made up of solvents and solutes. Okay, so what are solutes and solvents? Solutes are the part of a solution that's being dissolved. Usually you have less of this. A solvent is the part of a solution that dissolves the solute. Usually you have more of this. Okay, a solute and a solvent together equals a solution. We call the process of adding a solute and a solvent together solvation. You might call this dissolving, but solvation is just the process of making a solution. Some examples of solutes and solvents and what they make are over here in this chart. So if you add 2 solids together, you'll come up with steel, which is an alloy, which means that it is a metal made up of a combination of other metals. If you add a solid and a liquid together, you have ocean water. So you add the solid, which is salt, and the liquid, which is water, and that's your ocean water. A liquid and a liquid together could give you vinegar, and then gas and a liquid could give you carbonated water, which is disgusting. And if you like that, I have lots of questions for you. So, an example of this in the visual format for our visual learners is that you have a solute, sugar, what's being dissolved, which is added into the solvent, the water, what does the dissolving. It dissolves, and then you have a solution, the sugar, dissolved in the water. So here might be a fun way to remember the difference between solute and solvent. The robber hid the loot in the vent. The solute, like loot, goes in the solvent, like vent. Okay? You don't put the solvent in the solute. You put the solute into the solvent. So then what is solubility, which is the whole purpose of this lesson? Solubility is just the amount of solute that can be dissolved in a given amount of solvent. Different substances have different solubilities. And factors that can affect solubility include temperature, motion, and surface area, or how much space has been taken up. Within our solutions, we have three different types. We have unsaturated, saturated, and supersaturated. Unsaturated solutions contain less solute, or the material being dissolved, than could be dissolved. So in this example, we have Kool-Aid, which is it's kind of pale, which means you probably could have added more Kool-Aid to the Kool-Aid mix to this water, right? That means that you had less Kool-Aid mix than the water could have dissolved. It's unsaturated. A saturated solution is the maximum amount of solute that can be dissolved at a given temperature. So we can think of that as like our perfect Kool-Aid mixture. When you look at the bottom of the pitcher, you don't have any particles like at the bottom that haven't been dissolved. You don't have to keep stirring and stirring and stirring to get it dissolved. The Kool-Aid packet and the sugar have dissolved entirely into the water. Okay? That is what a saturated solution looks like. And then our super saturated solution, as you can see down here, you have the dry portion, you have the wet portion. The super saturated solution means that you have more solute, or the material being dissolved, in this case your Kool-Aid packet, than can be dissolved. That means there's not enough of your solvent to dissolve the Kool-Aid powder. Okay? So that's super saturated. So what is solubility then? This is a visual example of it. You have a powdered substance. This is nitric acid down here. You add a liquid to it, and all of a sudden, bam, you can't see the powdered substance anymore. Solubility. We have something called the universal solvent, which is water. We call water the universal solvent because it is very versatile because of its attraction to other molecules. Basically, that just means it dissolves more substances than any other liquid. It's capable of dissolving a variety of different substances. We know that if you give water enough time, it will even dissolve rock, which is how we have the Grand Canyon. So water is what we call the universal solvent. So, quick question for you guys. How would you make drink mix or Kool-Aid dissolve faster? There are three different ways that you might be able to do this, and I kind of touched on them earlier. All right, so thinking about Kool-Aid, the rate of solvation, or how fast a solvent and a solute come together and make a solution, would be increased. Agitating something, so shaking it. So, like if you've ever had one of those Kool-Aid packets that you can pour into a bottle of water and you shake it up, agitation. Surface area, so decreasing the surface area by mixing your solution, which is what you do when you make Kool-Aid in the picture. And then if you've ever made sweet tea, you should know that you should start with hot tea and you add sugar into the hot tea to quickly dissolve the sugar before you place it into a cold refrigerator, a cold refrigerator. Okay. So these are three different ways that we can affect the rate of solvation. Why do we even care about solubility? Why is it important to us? It's because we use it every day. You use it when you cook, when you make tea on a winter day, when you make Kool-Aid for a picnic, when you make hot chocolate on your snow days, or lemonade when it's hot outside. We are always dissolving something in water, okay? So think of solubility as just an everyday practice. Like I told you guys before, we science every day, okay? And that's the end of this lesson. Thanks, guys, for hanging out with me.